So now we're going to categorize some of the more difficult questions. The difficult ones tend to be like find the last. You had one in your homework that you were just doing that said find the last term, right? It doesn't specify it. Then for sure you need to know how many terms there are. If there's 13 terms, then the last one's term 13. Okay? This is, after example 3, I have one more example for you, or actually 2 more examples for you, that we have a blank page on page 751? Okay, yeah. 751 is a blank page. So the more difficult ones could be last term. Now, last term is probably the easiest of the more difficult ones. Sometimes they will ask you the middle term. So if I had, say, x plus y to the 16, which one is in the middle? It's not term 8. Are you just guessing now? Okay. How many terms are there? 17. Right? So there's 17 terms. And if you wrote out the numbers, wow, I shouldn't have chosen such a big number. Okay? If you write out the terms, there's 1 to 8 is 8 numbers. Can you see that 10, 11, 12, 13, 14, 15, 16, 17 is another 8 numbers, and term 9 is the one right in the middle? Okay? There will only be a middle term if you have an odd number of terms. Think about having 5. Your middle one is 3. I won't demonstrate that completely using my hand, but I think you get the picture. Right? Can give you the opposite demonstration to help you see that. Okay? If you have 3 fingers, then the middle one is, that's painful. Right? So the middle term can be a little bit more difficult. But the ones that we are going to look at right now are questions that have either the term containing or probably the most difficult, finding the constant term. So we're going to do a couple of these questions just to see what we're looking at. So here we can call this example 4. Find the term containing an x to the 9 in the expansion of 3x squared minus 2x, 3x squared minus 2 over x to the 9. So we have a couple of options here. How many terms are there? 10 terms. You could find all 10 of them, and one of them is going to have an x to the 9 when you're done simplifying. And then you'll be able to say, it's term 7 and it's this. But what we're going to do is we're going to look and see if we can figure out a way to do this that we don't have to figure them all out. Okay? Now, we have our formula for any term is n choose k, a to the n minus k, b to the k. The problem with this right now is we don't know which term it is. All we know is that it's going to be some number with an x to the 9. But because we don't know which term it is, we don't know k. So the number is going to be, are you okay if I write, I'm going to switch back to blue. Term k plus 1 is going to be something x to the 9. That's what we want. So that's going to be on the left-hand side. If we plug in everything we know into our formula, we would have n is 9. We don't know k. A is 3x squared to the 9 minus k. And b is negative 2 over x to the k. We can't do much with this because we don't know k. However, if we, and we'll write this down, if we temporarily ignore the coefficients, then on the left side, we would just have an x to the 9. And on the right side, well, 9 choose k is going to be some number that's going to affect the coefficient in front. We're going to ignore that. The 3 is going to affect the coefficient in front. We're going to ignore that. Can you see in the first one, the only thing you have would be x to then, if we use our exponent laws, x to the 18 minus 2k. And if we ignore the negative 2, because it's going to affect the coefficient, can you see that you would have an x to the k when you multiply them together in your denominator? And at this point, you can either, some people like to guess and check because you know that k has to be a whole number. The best way to guess and check in this example is to start with a k value you think won't work. Tell me a number. 11. Well, we do want to stay, because k can only, since, right, we only have 10 terms. We only have 10 terms. K can't be beyond 9, right? But it was a good guess at guessing one wrong, because you got it right off the bat. You could choose 9. If you pick 9, can you see that you would have x to the 0 on the top and x to the 9 on the bottom, which would, when you subtract it, give you x to the negative 9. So 9 doesn't work. So we try another number. So this is guessing and checking. And it actually doesn't take you very long. So after try 9, what do you want to try? Something less than 9? 6. If you put 6 into here, can you see that you would get 18 minus 12? So you would get x to the 6 on the top and x to the 6 on the bottom. That would cancel out and nothing would be left. We need more numbers on top. So k has to be smaller than 6. 4. 18 minus 8 would be 10 on the top, 4 on the bottom. Exponent laws, 10 minus 4, that gives us x to the 6. We're getting closer. 3. 18 minus 6 would be 12 on the top, 3 on the bottom. Can you see if you put in, if k is 3, that would simplify to x to the 9. So we could guess and check to get k is equal to 3. If you wanted to use algebra, and I have seen on a couple of exams they said, solve it algebraically. If you wanted to use algebra, this is what you would have to do. I'll switch to purple for the algebra. This side is x to the 9. You would still temporarily ignore the coefficients and get to the same place that we guessed and checked. What's your exponent rules for dividing? You subtract. What is minus 2k minus k? Minus 3k. And if x to the 9 equals x to the 18 minus 3k, so 9 would equal 18 minus 3k. 3k equals 9. K is equal to 3. Some people really like the algebra way. They're like, I think that's even faster than guessing for me. And that's perfectly fine. If you can't guess the right number, or if when you're guessing and checking you happen to guess the same number 5 times in a row, you may want to choose the algebraic method. bestest. There we go. So now that we've got K3, we know which term it is. Which term is it going to be? Term what? It's not term 3. We haven't finished this question yet. Which term is it? If K is 3, it's term 4. Because the term, according to the formula, is always K plus 1. And now we can go through and find the rest of the term. We know that our exponent was 9. It'll be 9 choose 3. Right? Our a value was 3x squared. 3x squared to the 9 minus 3. And our b value was negative 2 over x to the 3. Again, simplify each thing separately. 9 choose 3 is 84. 3 to the 6, is that 729? It is, yep. 729. X squared to the 6 will be x to the 12. Negative 2 to the 3 would be negative 8 over x to the 3. Multiply your coefficients together. So 729 times 84 times a negative 8. Negative 489,888. And x to the 12 divided by x to the 3 leaves us with x to the 9. So this question said find the term. It's not enough to find the position of the term. It's not enough to say it's term 4. You have to actually then go on and simplify and find the fourth term. So this is how you would do all the questions that say find the term containing. Okay, if we view the whole thing. What did we do first? We used the formula and put in everything that we knew, which was everything except for k. And so we had to solve for k first. We temporarily ignored the numbers in front because we were only going to use the exponents to help us figure out what k is. Once we solved for k, either by guessing and checking or algebraically, we plugged it back into the formula because now we knew everything and we could actually find the term and its value. And so that's find the term containing. Probably the most difficult one are the questions that say find the constant term in the expansion of and 5x cubed minus 2 over x to the 12th. Now, the first thing you have to have is an understanding of the language. What does it mean to be a constant term? What is a constant in mathematics? Go back to our grade 9 definitions. The letters are the variables. The number in front of a variable is a coefficient. A constant is just a number without a variable. In other words, you were close. In other words, another way we can think of it is it's the term containing x to the 0. And every year I put this in the video, somebody is going to ask me during the test or the quiz, what is a constant term? I'm like, sorry, the best I can tell you is that find all 13 terms and maybe one of them will jump out at you. But if you don't know what a constant term is, I can't help you on the test. So if that happens, you should watch this video again.
Yeah, let's go to the washroom.
Just go to the washroom. Ilya style. Take my phone with me. Okay. So we know there's 13 terms. If we take out our formula, tk plus 1 equals n choose k, a to the n minus k, b to the k, and plug in what we know that a term has no x's. So I can write x to the 0. Choose, and I don't know which term it is, 5x cubed to the 12 minus k, and negative 2 over x to the k. Once again, and I do want you to write this down while you're working on this, you write out temporarily ignore the coefficients. And so we would have x to the 0 equals, in my numerator, what would I have for exponents? I would have x to the 36 minus 3k. And in my denominator, I would have x to the k. What do we need? We need everything to cancel out for it to be a constant term. Do you want to guess and check, or do you want to use the algebra? Both. Both? Okay. Guess a value for k. Zeta. 8? Your name is not Zeta. 11 actually would be within the realm this time. So let's start with 11. If you pick 11, if k equals 11, yes, let Carter have his moment, you're going to get x to the 3 in your numerator and x to the 11 in your denominator. Do all the x's cancel out? No. What do we need? We need less in our denominator and more in our numerator. So then someone says, let's try k equals 9. And he'll have 27, which will give us x to the 9 and x to the 9. And once you've guessed and checked a couple times, you get really good at it. So we now know that k is equal to 9. If we were doing the algebra, x to the 0 equals, what's our rule? Subtract the exponents, so I'll get 36 minus 4k, so 0, 4k equals 36, and k is equal to 9. Now that we know that k is equal to 9, we can find term 10. Term 10 would equal, n was 12, choose k is 9, 5x cubed, 12 minus 9, and negative 2 over x to the 9. Again, calculate each of these things separately. So 12 choose 9 is 220. And 5 to the 3, 125. X cubed to the 3 would be x to the 9. Negative 2 to the 9 will be negative because it's to an odd number, negative 512 over x to the 9. Multiply our coefficients. And we can get some very big numbers. That's your coefficients multiplied together. And our variables all cancel out. So we're left with a term without any variables, which is a constant term. The constant term does not have to be the last term. It is always the last term in a polynomial, but these ones aren't polynomial expressions. Okay, try question number 9 for practice.